This is Dan Abbott, and I am about to evaluate a student project that was submitted in my Parametric Modeling class. And I decided to make a video to show the student where they had some problems and decided it might be a helpful video to others as well. So I've opened up a top-level assembly, an assembly that consists of several different sub-assemblies. And obviously I'm getting error messages, which means when the student did this, probably had it worked out so it looked pretty good, but something happened in between when they last looked at it and when they saved it. Now that's a lot of error. And if you look on the left, everything over here is red. So my solution to this, and the thing I would do and what I would tell the student to do, and I am telling the student to do, is don't try to repair this by going over here and trying to figure out what's wrong with each one of those mates. They're all red. Something seriously wrong, and I'm just going to go down and I'm going to highlight all of them and delete them and start over. Now that frees up this entire assembly, which is what was brought in to this top level assembly. There's only two things, a beam and then that trolley assembly. Now I'm going to look at the trolley assembly, and when I start moving it around I realize that there's no possible way that this trolley is assembled correctly, because in the real world, with the way this is set up, that cotter pin could never be in that position and prevent this from pulling apart. So something other than real world constraints. And yeah, you can see over here the cotter pin looks like it's got an interference of some kind. One thing I would always urge you to do is an interference detection before you do anything and submit anything to me. If I look at this, let's see if there are any interferences. Oh yeah, there's all kinds of interferences. Some of them we expect, and those are the interferences with the threads, and some of them we don't. So you see there's a lot of interferences here that just couldn't possibly be there, would prevent this from working. So we've got a problem with that. So now I have to go back to one of the sub-assemblies to do that. So I'm going to right click on this and open that sub-assembly. Now here's the sub-assembly. There was some mating being done to temporary axes and to origins. So I'm going to go up to the little eyeball and I'm going to turn those back off so that they're not in the way. But there's something clearly wrong here. Now in order to make this right, oh look at that. I'm able to move this all over the place. So to begin with, what's wrong is there is no one part that is holding this thing together. Anytime you have an assembly, that first part you bring in should be a part that is fixed in space so that it doesn't move around as you're trying to mate things. And so I don't know, they would have had a lot of trouble putting this together, and kind of impressive that they did it at all. What we really want in this case is that axle should have been the very first part brought in. It wasn't. It was the second part brought in. And when that first part was brought in, there's a green check that showed up that should have been selected that would have put the shaft at the origin and aligned with the same coordinate system as the assembly itself. Right now, if I look at the origin of the assembly, it's all the way over there. That's not where it should be. It should be on the same origin, at least if you want to pass the certification exam and if you want to prevent this kind of problem from happening. So the first thing I'm going to do here, since this is now free to float, I want to fix it in space. I'm going to fix it in space by creating a mate between the origin of the assembly and the origin of the long axle. Okay, so everything kind of rearranges itself over there. Now I at least have one part that's fixed in space and allows me to move these other things around. Okay, that's good. Now the other thing is the real world constraints that would be causing this thing to be in the orientation that it needs to be is that this plate, which has an angled hole through it, would go over that axle. Then those washers, which look like they are actually probably on there correctly, those washers, which are adjusting washers, would be there. And then the washers would come out against, yeah, and you can see this can't be bright because it has to be concentric with that hole. The washers would come out against the cotter pin, and that's what would hold the whole thing from coming apart. So I can tell, looking at this, that there is an artificial constraint because there's nothing that would cause those two things to behave together in the real world. In the real world, the position of those is going to be controlled by the position against that cotter pin. So I am now going to start closing things up as much as I can. And I've got two of these trolley assemblies, one here and one down here. I'm going to delete one of them because I don't want it to be related to the other one. And since I don't know how it was related to the other one, I don't really want to go through the process of trying to find out. I guess the nuts were put into this assembly. Now I'm going to do something else. I'm going to go and take that cotter pin right there. I'm going to delete all the mates on that cotter pin by right-clicking on it, going to the eyeball paper clip. It only has the one mate, which is the problem. So now, what would really hold that cotter pin in place is that the cotter pin would be put in that hole. If it was put in that hole, then that means the body of the cotter pin would be concentric with the hole. So I'm going to say, let's make a mate between that cotter pin and that hole right there. Got the control key held down, pick this, and I want them to be concentric. Now, this is going to be free to turn because there's nothing that would constrain it until it goes up against something. But I do want to make sure it doesn't go in and out. Now, this is one of those things a little tricky. There's no particularly good mate for stopping that from going down through. But there is a little vertex right here. And that little vertex shows up as a dot. I'm going to make it coincident with that face. And when I do that, just eases down, so now it won't go up and down, but it's still free to turn. Again, in the real world, in that position, it would be free to turn. Now what I'm going to do is I'm going to say take the surface of that washer, I've got the control key held down, and that edge right there, and make them coincident, because if they're coincident, that's what would hold the whole thing together. So now we've just done that, made them coincident. I think that washer is actually too small. But it's still going to work okay. So what that did was oriented itself so that the cotter pin is horizontal, which is the only way that could fit in there given the angle of those three washers. So now, okay, the axle came in like that, but what you can see now is that this whole side plate assembly on the axle is also now fixed because the axle is fixed. So this can't turn, nothing can happen to it. Now we're going to bring in another version of it. These nuts we'll worry about later. We're going to bring in another version of it by just going over to the side, holding the control key down, and then bringing it in. Well, one other little thing here. Yeah. One thing you don't want to do is put real threads on fasteners that are going to go into an assembly. They have a huge overload penalty. In other words, the computer has to calculate the geometry of those threads. Mathematically, that's far more complex than a cosmetic thread. So these really ought to have cosmetic threads, but they don't. So this thread that's cut in here, you can see that thread wouldn't actually work because it stops right there. The only time I would put a thread in a mechanical part in SolidWorks is if I planned to 3D print it and really wanted an actual working thread. So I would not want this because then it wouldn't work. So I'm just going to quickly open this thing up. We'll open that threaded part. And although I would actually suppress the thread and put a cosmetic thread on it, what I want to do is just show you how to get that to run out where you could actually screw something on it if you were to print it. I'm going to go to the thread and I'm going to offset the thread. When I offset the thread, I have to pick the direction. We'll go that way. So now the thread is offset so it goes past the end of that. And it doesn't matter how far past it goes, but I'm just going to leave it the way it is. And the other end conditions, they have it going up to the edge of that part right there. So that actually would work. Now when I get rid of this, you notice there's no more little step in this. So now if I go back to the third level assembly, which I've got right here, now I've gotten rid of that little step. Now that's not the problem with this assembly, it's just a problem. Now those nuts should be put on there, but that's easily done. I'm just going to move them out of the way because what I'm concerned about right now is putting this on in the right orientation so it sits on that axle and then constraining it the same way I did this with real world constraints and then see what the position is. We have another cotter pin problem here, and I think the washers are actually fine. The washers have been mated so that the origin of the washers is on the axis of the shaft, which is really what they would be. But that cotter pin, that's got problems. So I'm going to go and get rid of all the mates on the cotter pin, because that is the key thing that holds this whole thing together. The linchpin, as it were. So I'm going to take the cotter pin and just move it over here. Now, I'm going to make a concentric mate between the shaft and the hole of that, which is exactly where that would go. Now you notice this is free to turn like that, which it would be if we were assembling this in real life. It wouldn't be controlled by this because there's no relationship between them. I'll bring those washers over here. Let me just bend them. Oh, I'm going to come under here to see them. What I want now is for that face of that washer to be right up against the plate. So I'll make that a coincident mate. Everything got turned around kind of funny because of the way the washers were. But this is all going to resolve itself once we put real constraints on here. So now I'll move that over here, and you can see that's still free to turn. So we can, and it's not a bad idea to make things more or less in the position you want them to be. Now what would hold this in place? The cotter pin. So we're going to bring the cotter pin over. I'm going to put the cotter pin in, just to make it, well, it doesn't matter which way we do it. I'm going to put the cotter pin in so that the body of the cotter pin and the hole are concentric. And I'll do the same thing I did before. I did not mean to make that invisible. I must have picked, yep, I did pick the invisible button without noticing it. Now I'm going to do the same thing I did before. I'm just going to take that point right there and make it coincident with that surface, which means it won't go up and down, but it's still free to turn, which it has to be. Now, I'll back out just a little bit, and I'll turn that, or I can just barely see it. All right, what I'm going to do right now is take the face of that washer and that edge of that cotter pin and make them coincident. And when I do, everything turns into the only position that can possibly satisfy that mate. And now these things line up because of the reason they would line up in real life. The cotter pin stopped them from going out, and the only position where that could happen because of the angle of that hole, it's a position where the two things line up. There's no artificial mate between them, is what I'm saying. Let's just quickly, well, here's the problem with making this concentric. There's really no cylinder in there anymore. So we could make the edge concentric, but then that's just a spot. So the way I would do that is turn temporary axes back on, and then we would have to say make that axis and this axis, make them coincident. Now it comes in like this. Then make that surface and that surface coincident. Now the nut's on there and it's centered, so you aren't going to have, oh, I see. That's probably why they had an interference before, is because they tried doing concentric and that didn't work. They did something else. But again, I'll take the axis of this, the axis of that, make them coincident. Take that surface right there, and that surface right there, make them coincident. Now we got the nuts on. Again, that wasn't the problem with this. The problem with this was the other things we were dealing with. Now let's just get rid of all the things that are turned on here by just turning off the eyeball altogether. So now there's your whole trolley assembly, and it's in the orientation it needs to be in because of the use of those real world constraints. Now we go back to the final assembly where there were all those problems before. Now this is in better shape because it all works as one unit. And all we have to do now is to get it on here. This is helpful sometimes if you have 4 views, so that you can kind of move the whole thing into position and then kind of turn it so it looks a little more like what you want. You don't have to be really good with this, but it's helpful with those 4 views to at least get it close enough so it's less likely to be all skewed and to fool you into thinking that it's in a position that it isn't in. So close enough right there. Now I'm going to work in this view. So I'll hit the space bar. I'll say give me 1 window instead of all 4. And now what's going to keep that on the I-beam? That surface of the wheel. and that surface of the I-beam, those two things are going to touch. So control, pick them both, make them tangent. This one also has to touch. Make them tangent. And we need at least one more to really get this back in position, so that has to touch that surface. We'll make those tangent as well. That's actually enough. And one more and it's actually a redundant mate. We've got it over-defined. Now you notice that's sitting on there correctly. Slide back and forth. Looking at it from this front, it looks like that. Spacing is all even. Why? Because the cotter pins have the same number of washers. It's pushed out the same amount. And this is what I mean by real-world constraints as opposed to artificial constraints. So before, when making the top of that and the top of this parallel, that's not going to do that in real life. That's only something that works in SolidWorks. A few other things you have to do. You're going to have to limit distance made on here so it doesn't fall off the end and doesn't go past here. Hang the hook on there, and then this is fine. Last thing you do on every one of your assemblies, sub-assembly level, every single level, is go to evaluate, do an interference detection, do a calculation. Comes out on the whole thing, and it calculates it. Still waiting, taking some thought. All right, we have 4 interferences, and those 4 interferences, well, 3 I guess, possible, yeah. Those interferences, and it says possible because it's not exactly clear that it's an interference, but because the hole in the washer, the hole in the nut is the minor diameter, and the hole in the shaft of the axle is the major diameter, we expected those interferences. So there's no other interferences. We get rid of them by cleaning up the problems with the other assembly.